Welcome to today's deep dive. Today, we are looking at a highly specific product listing from HDTVSupply. It is the VPI CM-60W-110V Crimp Machine. And our mission today is to figure out why a single cable crimping tool costs exactly $3,130.
Yeah, it is. It's a really jarring number at first glance.
Right. I mean, a standard hand crimper is what, maybe 15, 20 bucks?
Yeah.
So, okay, let's unpack this. Because comparing a regular hand crimper to this VPI machine is like comparing a bicycle to a hydraulic bulldozer.
That is honestly a perfect analogy because what's fascinating here is that when you look at the specs, this isn't just a physical hand tool.
Right.
It's a machine that auto-terminates plugs using a combination of pneumatic air compressors and hydraulics, and it allows users to easily change the molds.
Which, by the way, those swappable crimping dies cost like $860 to $900 just on their own. But the craziest part to me, the specs explicitly mention it ships with the latest firmware.
Exactly. It's managed by dedicated firmware, and that's really the core of why this matters at an industrial scale.
But wait, I have to push back a little on the necessity of this.
Yeah.
Has the physical act of, cutting and pressing cables become so precise that our basic hand tools are basically computers now?
What?
I mean, a seasoned AV technician with a good manual crimper can terminate a Carry 6 cable perfectly in seconds. Are we just throwing software at a problem that human hands have already solved?
If we were talking about a standard office network, I would totally agree with you. A manual crimp is fine for that. But human hands, even highly trained ones, experience fatigue.
Oh, sure.
Right. I mean, a technician crimping their first cable at 8 a.m. applies a slightly different pressure than they do on their 400th cable at 4 p.m.
So the grip strength literally just changes.
Yeah, exactly. And in a high-end enterprise AV environment, that slight human fatigue introduces microscopic variations. Maybe the gold pins don't pierce the wire jacket to the exact millimeter, or, maybe the copper gets slightly deformed.
Okay, but how does firmware actually solve a mechanical issue like that? How does software interact with the physical crush of the plastic?
Think of it like the anti-lock braking system in your car.
Okay.
When you slam on the brakes, the ABS computer calculates wheel slip thousands of times a second, right? It dynamically adjusts the hydraulic pressure. This crimper operates on a really similar principle.
Oh, wow.
Yeah, the firmware actively monitors the physical resistance of the specific die and the materials being compressed in real time. It tells the hydraulic system exactly when to ramp up force and exactly when to stop.
So it ensures the copper is seated with, mathematical perfection without crushing the internal shielding.
Precisely.
So it's actively adapting to the resistance during the actual microsecond of the crimp. That totally explains the hardware, but let's connect this to the bigger picture. HDTVSupply caters to massive installations.
Right, their whole ecosystem.
Yeah, we were talking about this huge 160 by 160 HDMI matrix switches and 4K AV over IP networks.
Networks designed to run 100 TVs simultaneously. And that ecosystem is exactly why this level of precision is mandatory.
Because of the amount of data.
Exactly. When you are pushing uncompressed 8K video across a commercial network, you're dealing with astronomical data loads operating at incredibly high frequencies.
Right.
At those frequencies, the physical wavelength of the signal is tiny. That means a microscopic misalignment in a single RJ45 pin caused by a slightly weak hand crimp creates signal reflection.
Wait, so the data literally hits a physical defect in the connector and just bounces back down the wire?
It does. It bounces right back and causes massive packet loss.
And I'm guessing you'd notice that. In a regular data network, the system just resends the packet, right? Like your web page loads a millisecond slower and you never notice.
Exactly. But in an uncompressed live video matrix, dropped packets mean artifacting, stuttering, or an entire display just dropping offline completely.
Which, if you're running a massive sports bar on a Sunday, one dropped video matrix because of a millimeter of bad crimp is a catastrophic failure.
Yeah, you simply cannot afford a technician's 4 p.m. hand fatigue.
So this $3,000 machine is essentially an insurance policy against physics.
That's a great way to put it. It removes the human biological variable from the equation entirely. You get the exact same molecular level contact on cable number 1 as you do on cable number 10,000.
That is wild. It really changes how you look at the infrastructure around you.
Oh, absolutely.
I mean, the next time you are sitting in a massive sports bar, just effortlessly watching 40 different games on 40 different screens without a single flicker, you'll know that a hydraulic, firmware updated $3,000 machine is the hidden hero keeping those feeds running flawlessly.
It really is the invisible backbone of modern entertainment.
Yeah.
And, it leaves you with a pretty interesting thought to ponder. Well, if the physical hand tools we use to build basic cable connections now require their own microprocessors and dynamic hydraulic feedback loops just to attach a plug, how long until the raw network cables themselves are actively monitoring and diagnosing their own physical health?